Week 3 Part A. How we measure human comfort performance requirements. The aims of this session are as follows. 1. To recap the 6 personal factors that will affect human comfort. 2. List the 7 main methods of how we measure human comfort in a building. Last week we covered the 6 main personal factors that will affect human comfort. Try to remember them and answer the following questions. You will see that there are a list of 7 personal factors that affect human comfort. One of these is incorrect. Please identify the incorrect one. Race and religion are not personal factors that will affect your human comfort in a building. The correct ones are as follows. Clothing. This is one of the most important factors that will affect a person's perception of humans' comfort. For example, everyone wears different amounts of clothing, and therefore this will change if you are feeling hot or cold. 2. Level of activity. The amount of physical activity you are doing will change the amount of heat you are generating within your body. This is based on a scale called the metabolic equivalent. For example, if you sit in a chair, your metabolic equivalent is 1. However, if you jog, your metabolic equivalent is 7. Your body will generate 7 more times heat. This is why a person gets hot when they are jogging, rather than sitting. 3. Personal metabolic rate. Generally, all persons have a different metabolic rate. This is the speed that the body burns up energy, that creates heats and cooling in a body. 4. State of health. A person's state of health is important. Generally, if you are unwell, your metabolic rate will lower and your body requires a higher air temperature. Fit, healthy people generally are able to generate more own body heat as they burn up more energy. 5. Age. The age of a person will also affect the metabolic rate. Generally, the older we are, the less energy our body uses for regulating heat and cooling. 6. Gender and size. This is to do with the average surface area of a person, as generally the larger you are, more surface area you have, but a lower surface area mass ratio you will have. How do we measure human comfort in a building? Consider the room in which you are sitting in at the moment. How would you measure if the human's comfort performance requirements are correct or not? Make a list of as many ways of how you would measure these humans' comfort performance requirements. The most common method to measure the room's temperature would be to use a normal room thermometer. This is actually known as a dry bulb air temperature thermometer. These thermometers measure the air temperature. However, they must be kept away from a heat source or sunlight, as this will drastically affect the reading. When we measure air temperature, we can measure it in 3 units. What are they? Throughout the world, there are many different units of measuring temperature. The 3 most important ones are Fahrenheit, Celsius, and Kelvin. Celsius, also called centigrade, is a scale based on 0 degrees for the freezing point of water and 100 degrees for the boiling point of water. This system was invented in 1742 by the Swedish astronomer Anders Celsius. Some still call it the centigrade scale because of the 100-degree interval between the defined points. The Celsius scale is part of the metric system and is used to measure the temperature in many countries. It is the easiest scale to use, and though it is used throughout the world, there is one exception, the United States. In the US, the Fahrenheit scale prevails, but the Celsius scale is also not accepted in certain places where Kelvin is used. Fahrenheit. This temperature scale is based on 32 degrees for the freezing point of water, and 212 degrees for the boiling point. The interval between the 2 points is divided into 180 equal parts. The German physicist Daniel Gabriel Fahrenheit devised this scale in 1724. The Fahrenheit scale is mostly used in the United States and some of its territories. Kelvin. This temperature scale is named after the British mathematician and physicist William Thomson Kelvin, who proposed it in 1848. It is an absolute temperature scale, having an absolute 0 below which temperatures do not exist. Each unit on this scale is called a Kelvin rather than a degree. For this reason, just the K, not the degree symbol degree, is used when reporting temperatures in Kelvin. There are no negative numbers on the Kelvin scale, as the lowest number is 0 K. Absolute 0 cannot technically be achieved. It is the temperature at which molecules would stop moving. It is thus infinitely cold. The globe thermometer was introduced by Vernon in 1930 as a means of assessing the combined effects of radiation, air temperature and air velocity on human comfort. It consists of a hollow copper sphere painted matte black to absorb radiant heat, with a temperature sensor at its center. When it reaches a steady state, after 15 minutes or so depending on the size of the globe and the environmental conditions, the heat exchanges by convection and radiation will be in equilibrium, and the temperature recorded by the sensor will be somewhere between the air and radiant temperature. This is referred to as the globe temperature or black globe temperature and resembles the thermal conditions felt by the human body. The wet bulb temperature is the temperature read by a thermometer covered in water-soaked cloth over which air has passed. The temperature recorded is lower than dry bulb temperature by the effect of water evaporation from the cloth. The rate of evaporation and the temperature recorded will be affected by the humidity and moisture content of the air. Wet bulb temperature is useful to gauge real temperature felt by a person sweating or by wind chill factor. A hygrometer is an instrument used to measure the amount of water vapor in air. The amount of moisture is measured as a percentage of the amount of possible water vapor that the air is able to hold. If we have 100% humidity, then the moisture would drop out of the air as the air has reached the water vapor saturation. As relative humidity affects a person's ability to sweat and cool down, it is useful to help predict how a person will feel. If you have a high humidity you will feel hot and sweaty, while a low humidity you will feel colder, and possibly have a dry throat and dry itchy eyes. An anemometer measures wind speed. Indoors, an anemometer measures airspeed, air velocity or airflow. The airflow rate in buildings is often measured in meters per second using anemometers to assess the performance of heating, ventilation and air conditioning, HVAC, systems and equipment. Apart from measuring ventilation rates, the anemometer can measure drafts from air vents or doors or windows. A high velocity will make you feel cooler or be perceived as an unpleasant draft. A light meter is a device used to measure the amount of light. Light meters are used in the general field of architectural lighting design to verify proper installation and performance of a building lighting system. The light is measured using a light unit known as a lux. Generally 1 lux is equal to a candlelight spread over a meter squared. A sound level meter is used for acoustic measurements. It is commonly a handheld instrument with a microphone. Sound meters can be used to either measure the volume of specific sounds or background noise in a building. Sound meters commonly measure the sound value in watts, but is then converted to decibels.